everyone, welcome to GATE Academy and welcome to the next session of BARC Formulathon series. So today we will be discussing thermodynamics. है ना? So I hope everybody is ready. So please make your copies with you. So हम मतलब starting से equations लिखना start करेंगे, formulas discuss करेंगे. So thermo 1 से start करते हैं first of all. Classical thermodynamics. So thermodynamics. So I'm starting with thermodynamics 1. So in thermodynamics 1, okay, in thermodynamics 1, what are the topics we have? So first of all, in thermodynamics 1, we start with the chapter pure substances. So in pure substances, we don't have much equations to discuss, okay? So from your process calculation, आपको थोड़ा equations remember करना होता है. So first equation to remember is obviously equation of state, okay? Equation of state, so we need to remember PV is equal to nRT. Okay, PV is equal to nRT. So if they are asking to find density of a gas, P into molecular weight R into T. So this you should remember. Okay, this you should remember. The second equation is what? Second equation is another equation of state. What is the second equation of state? In the equation of state, two assumptions you need to remember. Okay, so the ideal gas molecule does not have that molecular attraction is very negligible. We are not considering the molecular attraction, and molecules possess zero volume. These are the two assumptions in ideal gas equation of state. The next equation of state is Wonderwall's equation of state. So you should remember Wonderwall's equation of states equation P plus A by V square V minus B is equal to RT. So for finding the constants of this Wonderwall's equation, we use dou P by dou V is equal to 0, dou square P divided by dou V square is equal to 0. This is based on what? This is based on your critical point. Okay, so your critical point in pure substances, critical point is a point of inflection. So based on that inflection point, substituting, you will find the value of the constants in any cubic equation of state. इतना तक आपको याद रखना in the pure substances chapter. Then what? Then maybe extra thing you can remember is compressibility factor equation. Compressibility is equal to volume of real gas divided by volume of ideal gas. Okay, or Z is equal to PV by nRT, and compressibility factor, right? Compressibility factor can be calculated, right? Compressibility factor can be calculated based on TR, PR, where TR and PR are reduced pressure and reduced temperature, right? Compressibility factor you can write in terms of TR and PR. So where TR is, what is TR? TR is the temperature divided by critical temperature. PR is pressure divided by critical pressure. Okay, so these are, yes, good evening. So these are the equations you need to remember in the pure substances chapter. Okay, pure substances chapter. So most of the pure substances is based on your process calculation as well. Process calculation से भी questions आता है, right? Process calculation, thermodynamics mix होता है. So that is also you need to remember. So that is the end of pure substances chapter. Okay, this much is enough. Okay, this much is enough. So in thermodynamics, so most important chapter is first law of thermodynamics chapter. So next question or next topic or next chapter is first law of thermodynamics. So what is your first law of thermodynamics? According to our sign convention, chemical engineering sign convention. Okay, according to our chemical engineering sign convention, I write du is equal to del Q plus del W. This is according to chemical engineering sign convention. Okay, du is equal to del Q plus del W, or we can say delta U is equal to heat transfer during process 1 to 2 minus, we write it as PdV. Because our del W is minus PdV, right? For chemical engineers, we write it as minus PdV, so that is correct. Okay, so this is the equation. Now remember your heat and work, right? Heat and work, or you can write like this as well, that is plus work transfer during process 1 to 2. So this is according to our sign convention. Those who use mechanical engineering sign convention, they can use minus, doesn't matter. Okay, now remember, heat and work are path function, and all the other properties, right? All the property, internal energy, enthalpy, right? Or Gibbs free energy, all properties are state function. So this delta U, I can write it as U2 minus U1. So U2 minus U1 is equal to Q12. I cannot write it as Q2 minus Q1 because Q is a path function. है ना. हीट जो है वो पाथ फंक्शन है, वर्क जो है वो भी पाथ फंक्शन है. सो दिस इज योर इक्वेशन फॉर व्हाट, ये आपका इक्वेशन है, राइट. दिस इज योर इक्वेशन फॉर व्हाट, first law of thermodynamics, right? First law of thermodynamics. Now once the first law of thermodynamics is discussed, right? एक बार first law of thermodynamics हो गया तो you have different processes. Okay, ideal gas equation of state base करके, और ideal gases में, right? If you have different processes, एक constant volume process है, constant pressure process, adiabatic process and isothermal process. We need to discuss 4 processes. Now, so after this, the important equation you need to remember is for ideal gas, can say delta H is equal to, right? Delta H is equal to H2 minus H1, or you can say it is integration of number of moles into CV dt, or sorry, if it is delta H, it will be Cp. Delta U is equal to U2 minus U1, this is equal to integration of NCV dt. So these 2 equations are valid, right? These 2 equations are valid for ideal gas. So जो भी प्रोसेस होगा, राइट, जो भी प्रोसेस होगा, दैट डजंट मैटर, ये दोनों इक्वेशंस वैलिड रहेगा आपके लिए, राइट. वॉट एवर बी द इक्वेशन, both equations are valid for you. Now we are starting with what? We are starting with the each processes. So let us see each processes in detail. First process, ideal gas process, ideal gas property relation. First process is constant volume system. First process is constant volume system. In constant volume system, okay, in constant volume system, we have du equal to del q plus del w. But if in constant volume system, del w is minus pdv, so dv is 0, so this will be equal to 0. So we can say what? आपका जो internal energy change होगा, that will be equal to del q. So if you integrate this, right, if you integrate this, or ideal gas process में, ideal gas में constant volume process हो रहा है, तो du I can substitute it as cv dt as well. Now delta u, if I integrate this, this will be equal to heat transfer during 1 to 2, which is also equal to integral of ncv dt. So this is the complete equation for constant volume process. Yes, Aditya, good evening. So this is the complete equation for constant volume process. So understanding the equation is very important, है ना? So constant volume process हो गया, ठीक है? So first law equation लिखना है आपको, ठीक है? My del W is minus PdV, so volume change is 0, so 0 हो जाएगा, ठीक है? So remaining is easy. So the CV dt is equal to du is for all processes in ideal gas, okay? CV dt is equal to okay, Aditya is asking how many questions should be attempted to get called. So Harshit sir just told actually, you have to attempt more than 65. Okay, 65 should be correct, right? Then only you can expect the call. Okay, so more than 65 minimum should be correct. Okay, so that's what sir told. Okay. Question number 2, constant volume is done. So second type of system is constant pressure system or isobaric system. Okay, isobaric system. So what is the speciality of isobaric system? Okay, isobaric system. So we will see isobaric system also. du is equal to, right, we are going to write the same equation, del q minus pdv. So if I take that minus pdv this side, du plus pdv will become del q. This du plus pdv is your enthalpy. H is equal to u plus pv hota hai na, H is equal to u plus pv. So du plus pdv, we can write it as your enthalpy change. So enthalpy change is equal to del q. So enthalpy change is what? Enthalpy change is Cp dt for ideal gases. Right? Enthalpy change is equal to Cp dt for ideal gases. So we can say delta H by integrating. Delta H is equal to whatever heat transferred during process 1 to 2, it will be equal to integral of n into Cp into dt. Now, सोच सकता है sir, why it is n, why it is not m? So Cp के यूनिट जो भी आपके क्वेश्चन में दिया है उसके हिसाब से आपको नंबर ऑफ मोल से मल्टीप्लाई करना है या मास से मल्टीप्लाई करना है, that you can decide. Okay, number of moles or mass, right? That can be decided by the unit of Cp. Okay, Cp or Cv, whatever. Up to this is fine. Now once this is done, right, once this is done, this is what, this is our isobaric and isochoric, right? This is isochoric, constant volume, this is constant pressure, isobaric. Now once both are done, right, once both are done, we have a third process is isothermal process. So most of your questions are always from isothermal process or adiabatic process. So remembering the equations for isothermal process is very, very important. Okay, so isothermal process, we know general equation, first law equation is du is equal to del q plus del w. Now we know du for ideal gases is equal to cv dt. So isothermal का मीनिंग क्या है? isothermal मतलब टेम्परेचर चेंज नहीं होगा, so ये 0 हो गया, है ना? isothermal के लिए du 0 हो गया, so whatever is your del w will be equal to minus del q, or if you integrate we can say whatever work transferred is equal to q12 negative. So why there is a negative? Because this is according to our sign convention. Now इसका physical meaning क्या होगा? मतलब whenever you compress something, right? सोचो, whenever you compress something, हमें क्या करना पड़ेगा? We have to supply work. Okay? When you compress something, we have to supply work. Clear? So when we compress something, what will happen to the temperature? Temperature will increase. है ना? जब भी हम compress करोगे, right? Whenever we compress, आपका temperature increase हो जाएगा. लेकिन जब isothermal process है तो क्या है? टेम्परेचर कैनॉट बी इंक्रीज, तो हम क्या करेंगे? हीट को रिलीज करेंगे, है ना? whenever temperature is increasing, heat will be released. So work required for compression, अगर हमने 100 जूल दिया है, work required for compression करने के लिए 100 जूल दिया है, to keep isothermal compression, what we have to do, उसी 100 जूल को हम बाहर रिलीज करेंगे. We have to release the 100 joule to outside. So that's why heat released is negative for us, right? So इसलिए we are getting this equation. Okay, so this is easy. Now if you want to find the heat transferred, आपको work calculate करना ही पड़ेगा. So how do you calculate work in case of an isothermal process? So del W is equal to minus of PdV. So if you want to find work transfer during 1 to 2, we have to integrate PdV. So P के जगह पे हमें substitute करना पड़ेगा. If it is an isothermal process, we have PV is equal to constant. So C by V substitute कर लो, you will get work for an ideal gas process of isothermal process आपको मिल जाएगा minus C ln V2 by V1. Minus C ln V2 by V1. So हमें पता है C के वैल्यू क्या क्या हो सकता है. What can be the values of C? C का वैल्यू हो सकता है minus P1 V1 ln V2 by V1 हो सकता है ना? It can also be minus P2 V2 ln V2 by V1 हो सकता है, और it can also be minus nRT into ln V2 by V1 हो सकता है. And why there is a y minus sign? Because ये हमारा chemical engineers के लिए sign convention के हिसाब से हमें एक minus आता है बस. Right? Otherwise there is no minus. Okay? So this is the meaning. So I hope up to this is clear for everyone. है ना? So these are the equations for what? Your isothermal processes. Same equation आपको दोबारा तीनों equation, 3-4 equations you can write it again by changing V2 by V1 is equal to P1 by P2. है ना? V2 by V1 के जगह पे P1 by P2 लिख के आपको फिर से इक्वेशन लिख सकता है. कोई जरूरत नहीं है, क्योंकि आपके इक्वेशन आपके क्वेश्चन के हिसाब से अकॉर्डिंग टू द गिवन वैल्यूज यू हैव इन द क्वेश्चन यू नीड टू सेलेक्ट द इक्वेशन. Easy. So this is the third part. I hope up to this is clear for everyone. Now let us see, isothermal is done. Next is adiabatic. Fourth is adiabatic. Let us see adiabatic process. If it is an adiabatic process, what is the meaning of adiabatic process? Yes, if it is an adiabatic process, the meaning is we are not allowed to transfer heat to the surroundings. That is, we cannot transfer heat to the surroundings. So whatever work given will be used for what? Increasing the temperature. Automatically आपका temperature increase होगा. Compression कर रहा है ना? Temperature तो increase होगा ही. Okay? So temperature will increase. So since the heat is not allowed to go out, क्या होगा? Right? Your temperature will increase. Isothermal में क्या हो रहा था? Heat is allowed to go out, so आपका temperature was going down. Okay. Now you can see adiabatic. You have the first law equation. du is equal to del q plus del w. Okay. So del q is cancelled out. So we can say delta u is equal to whatever work transferred, which is also equal to integration of n cv dt. So in any question, right, in any question in gate adiabatic, if they are asking you work required, right, work required in case of an adiabatic process, आपके पास दोनों temperature और CV के value है, तो ये equation easiest equation है, right? This is the easiest equation. Now, what are the other equations? What are the other equations for finding work? W12 will be equal to minus integral of PdV, and you should know adiabatic process means PV power gamma is equal to constant, so gamma hota hai Cp divided by Cv. So substitute this, you will be getting what? Work required. Work 1 to 2 will be equal to, you will be getting, I think, P1 V1 minus P2 V2 divided by gamma minus 1. Or you have different equations, right? Nr T2 minus T1 divided by gamma minus 1. I think it will be P2 V2 minus P1 V1 according to the sign convention. It will change, okay? Doesn't matter. Nr T2 T2 minus T1 divided by gamma minus 1. Same way, if you take P1 V1 outside, you have several equations, okay? P1 V1 divided by gamma minus 1 into P2 by P1 power gamma minus 1 by gamma minus 1. These are the total equations you have in adiabatic processes. Okay, so other than remembering this equation, you should know the derivation. So in case if they ask, you should be able to solve. Now, most important adiabatic relation in gate is, or in BARC is, T2 by T1 is equal to V1 by V2 power gamma minus 1, which is also equal to P2 by P1 power gamma minus 1 by gamma. So this is the most important relation in thermodynamics adiabatic processes. This is the most important relation. So they can ask you several questions. In the mock test 1, there was a question based on this question, right? This equation. ठीक है? So ये सब आपको remember करना है. So I hope it is clear for everyone. T2 by T1 is equal to this. So with this, right, with this, your complete questions are done. Right, with this almost all the first law chapter questions is done. Once this is over, right, once this is over, you have what? You have a topic called free expansion. You have a topic called free expansion. Free expansion is another topic you have. That is, what is the meaning of free expansion? That is, you have a gas in one side of the thermodynamic system. We have a system, and in the one container, one side you have gas, and the other side is evacuated. Okay, so gas temperature is Ti, initial volume is Vi, pressure is Pi, whatever. Now what they are doing, right, what they are doing, this particular container is insulated as well. This container is insulated as well. Now, when this barrier is broke, right, if you remove this barrier, what will happen? Gas will fill against vacuum. If it is an ideal gas, the work done against the vacuum will be always zero. Okay, the work done against, the gas is filling against vacuum, so work done against the vacuum will be zero, and since it is insulated, आपका जो heat transfer भी zero होगा, so for an ideal gas, delta U भी zero होगा. So del W plus del Q होता है ना, del U, according to your first law of thermodynamics. So del U भी zero होगा. So for ideal gas, U is a function of temperature only for ideal gas. For ideal gas. So what is the speciality of this particular free expansion? Whenever after expansion, normally अगर यहाँ पे vacuum नहीं है, right? If there is no vacuum, right? Normally after expansion आपके temperature क्या होना चाहिए था? Down होना चाहिए था, decrease होना चाहिए था, right? Decrease होना चाहिए था, लेकिन यहाँ पे क्या होगा? After expansion, your initial temperature and final temperature will be similar. Your initial temperature and final temperature will be similar. Now, Remember, if it is a real gas, your final temperature will be low. Temperature will decrease if it is a real gas. Now, if it is an open system, we have studied that as well, right? मैंने बहुत सारे lectures में बताया भी है. If it is an open system and if you are having a filling, right? Initially मतलब container एक vacuum container है, ठीक है? Insulated सब कुछ दिया है, and you have an inlet. Right, you have an inlet coming in. उस केस में क्या होगा? Final temperature जो inlet temperature से ज्यादा होगा. So, मैंने क्लास में भी आपको 3 केसेस बताया था. एक फ्री एक्सपेंशन है इन केस ऑफ क्लोज सिस्टम, व्हेन द गैस इज फिलिंग अगेंस्ट वैक्यूम, इनिशियल एंड फाइनल टेम्परेचर आइडियल गैस में सेम होगा. रियल गैस है तो क्या होगा? टेम्परेचर डिक्रीज होगा. इफ इट इज एन ओपन सिस्टम, ये क्या होगा? अगर ओपन सिस्टम है तो क्या होगा? आपका टेम्परेचर विल बी इंक्रीजिंग. Okay, so these 3 things you need to remember, right? You need to remember the 3 things. So this is one case. In the other case, right? In the other case, I was saying, this was the case I was discussing. That is, ये भी हमने क्लास में किया है. That is, you have a vacuum inside the container, right? Vacuum inside the container. This is completely insulated, and you are filling an ideal gas, right? You are filling an ideal gas through a constant pressure line. Constant pressure line say you are filling an ideal gas, the initial temperature is Ti. So after some time, right, after some time, the final temperature Tf, the final temperature Tf will be gamma times Ti. So this also we have proved, right? This also we have proved. So since the gamma is greater than 1, so obviously your final temperature will be more than initial temperature. This is in the case of open system. Clear? This is in the case of open system. ये भी आपको याद रखना होगा. Now, once this is done, you have first law for open system. What is the equation for first law for open system? First law for open systems. So we have, yes Rahul, that is correct. So we have d by dt of mass into internal energy of the control volume plus outlet minus inlet, right? Outlet minus inlet, I am writing it like this, m dot into h2 minus h1, this is the enthalpy change, plus change in kinetic energy plus change in potential energy is equal to heat transfer rate plus shaft work, right? Heat transfer rate plus shaft work. So if it is a steady flow device, if it is a steady flow device, अगर ये डिवाइस आपके क्वेश्चन पे स्टडी फ्लो डिवाइस दिया है तो क्या हो जाएगा? दिस डी बाई डी टी ऑफ मास इनटू इंटरनल एनर्जी वैल्यू विल बिकम 0, है ना? डी बाई डी टी ऑफ मास इनटू दिस वैल्यू विल बिकम 0. एंड इफ इट इज अ स्टीम टर्बाइन और टर्बाइन, स्टीम टर्बाइन में क्या होता है जनरली, राइट? स्टीम टर्बाइन में क्या होता है जनरली? आपका डेल्टा एच विल बी इक्वल टू शाफ्ट वर्क. मतलब स्टीम टर्बाइन में क्या होता है? द एक्सपेंशन, राइट? एक्सपेंशन के टाइम पे जो एंथैल्पी चेंज होगा, दैट एंथैल्पी चेंज इज कन्वर्टेड टू व्हाट? शाफ्ट वर्क, right? Because turbine is producing work, right? Turbine is producing work, so that steam turbine case delta H will be equal to shaft work. These also you should remember. And हम सबसे ज्यादा शाफ्ट वर्क कब मिलता है हमें, राइट? व्हेन वी विल बी गेटिंग मैक्सिमम शाफ्ट वर्क, वी विल बी गेटिंग मैक्सिमम शाफ्ट वर्क इफ इट इज आइसेंट्रोपिक एक्सपेंशन, राइट? इफ इट इज एन आइसेंट्रोपिक एक्सपेंशन, सो आइसेंट्रोपिक प्रोसेस है तो यू विल बी गेटिंग मैक्सिमम शाफ्ट वर्क. ये सब याद रखना है आपको. Okay, so this is your first chapter. Okay, this is your first chapter, that is the application of first law to open and closed system. Already pure substances हमने discussion किया है, ठीक है? So this up to this is clear, I hope. So we are moving to, right? We are moving to our next chapter. Next chapter is what? Second law of thermodynamics. Second law of thermodynamics. We are moving to second law of thermodynamics. So in second law of thermodynamics, it's very easy to remember the equations. We have what? Heat. What is the first equation you need to remember? Efficiency of a heat engine. What is the efficiency of a heat engine? That is out of QH, out of the heat given to the heat engine, how much we are able to convert it into work. So it will be QH minus QL divided by QH Okay, so this is 1 minus QL by QH. If it is a Carnot heat engine, what is the speciality? If it is a Carnot heat engine, you can write QL by QH as TL by TH. If it is a Carnot heat engine. Same way, what is the COP of a refrigerator? What is the COP of a refrigerator? So refrigerator, the objective is to take maximum QL out of the work input. Okay, so the equation is QL divided by QH minus QL. So your equation will be this. So what about COP of heat pump? COP of heat pump is QH divided by work input. So your both refrigerator and heat pump, okay? So your both refrigerator and heat pump works on the same ब्लॉक डायग्राम है ना, सेम ब्लॉक डायग्राम के ऊपर वर्क करता है, लेकिन आपका क्या चेंज होता है? ओनली द ऑब्जेक्टिव इज डिफरेंट. सो दिस इज योर इक्वेशन. नाउ इफ इट इज कार्नोट, राइट, इफ इट इज कार्नोट, और यहां पे आप देख सकते हैं कौन सा वैल्यू ज्यादा होता है? सीओपी ऑफ हीट पंप इज इक्वल टू रेफ्रिजरेटर प्लस 1 होता है ना, रेफ्रिजरेटर प्लस 1. यस, सीओपी ऑफ रेफ्रिजरेटर प्लस 1 is equal to heat pump. Because if you add plus 1 here, what will happen? QL cancel होगा, QH by QL आ जाएगा. Okay, so same way, if it is Carnot heat pump or Carnot refrigerator, instead of QL by QH, you can substitute TL by TH in Kelvin. Okay, if it is a reversible or Carnot heat engine, or Carnot, reversible or Carnot. That's all. Yes, yes, Joseph, that is COP of a heat pump is equal to COP of refrigerator plus 1. So if it is Carnot is given, means jitne bhi equations hai, whichever equations is given, Carnot means you can substitute it. That's all. Okay, TH by TL, so problems will be solved. Done. I hope it is clear. So these are the maximum questions from your second law of thermodynamics. Once we finish the second law of thermodynamics, we are moving to what? We are moving to your entropy, right? In entropy, what are the things you need to remember, right? In entropy, what are the important things you remember? So one more thing I wanted to say is, most of the cases, right, most of the places, they will be asking you, once you clear the BARC exam also, they will be asking you one question: can you define entropy, right? Can you define entropy? Okay? So can you define entropy? That question will be always there. So the entropy you can always define as, always don't say like randomness, disorder, etc. because वो definition तो हर जगह पे है, right? That definition is everywhere. So try to always define entropy in a different way. Like you can say it is quantifying the loss of quality associated with energy transformations. Okay? So entropy is giving us the idea of how much quality is lost. Okay, that is the meaning of entropy, right? Whenever there is an energy transformation, right? Whenever there is a heat transfer, you can imagine like that. Okay, जब भी एक heat transfer हो रहा है ना, we are losing some quality. Okay, we are losing some quality. For example, सोचो, right? So there is a temperature difference and there is a heat transfer is happening. Okay, so actually, is there energy is always conserved, no? Right, energy is always conserved. That is, hot fluid is losing energy, cold fluid is gaining energy. So energy is conserved, right? Energy is conserved, but we are losing something. What we are losing? We are losing our ability to do useful work, right? We are losing some quality, right? We are losing some quality, right? So after every energy transformation, we are losing some quality. Right? So entropy is saying what? Entropy quantifies that loss of quality associated with energy transformations. I will explain that, right? I will explain that definition, right? That will be different. So always entropy quantifies the loss of quality associated with energy transformations. Okay, that is the meaning of entropy, right? That is the meaning of entropy. Entropy is increasing, right? Entropy is increasing, but when the same time entropy is increasing, we are losing something in the side also, right? Randomness is increasing, but we are losing our quality. Some quality is decreased. So that I will explain in detail, but remember that. So before that, what is entropy, right? What is entropy? Entropy is derived from your Clausius inequality. Clausius inequality is del Q by T is less than equal to 0. So this is valid for all cycles. Okay, this is valid for all cycles. Now, if I say cyclic integral of del Q by T is equal to 0, this is valid for only reversible cycles. This is valid for only reversible cycles. Okay, this is valid for only reversible cycle. If I say del Q by T is cyclic integral of del Q by T is less than 0, this is valid for irreversible cycle. So, if you take an example of Carnot cycle, right? If you take an example of Carnot cycle, cyclic integral of del Q by T का value आपको 0 आना चाहिए, right? That is the point, because Carnot is a reversible cycle. Okay, Carnot is a reversible cycle. Now, same way, if you take any normal cycles other than Carnot cycle, like actual heat engine, actual refrigerator, the value should be less than 0. Now, so scientists, what they are seeing is, we have something whose cyclic integral is 0. So, what is the value of cyclic integral of volume change? 0. Cyclic integral of temperature? 0. That is, for a cycle, your initial and final values will be always same. That is, if you see a process, this is process 1 to 2. This is process 2 to 1. So always for a cycle, your initial and final value of properties will be same. Okay, so same way, like your temperature, pressure, or your internal energy, enthalpy, or like that, we have some property here. Right, we have some property whose cyclic integral is 0. So they have named it as entropy. So they are saying ds is del Q by T reversible. Okay. Okay, so Sarila is asking, sir, can we say as entropy increases, availability decrease, or we can say quality decreases, not availability. Generally, quality associated with energy transformations decreases. Okay, so quality decreases actually. Now that I will explain. Don't worry, I will explain with an example. So let me just introduce this. So delta S. What is the equation of delta S? Delta S is always S2 minus S1. Delta S is S2 minus S1. Final, matlab, aise socho, you have a process. This is your process 1 to 2. What is the entropy change during the process? S2 minus S1. This is equal to integral of 1 to 2 del Q by T plus entropy generation. Okay, so this is your basic equation of entropy change. Now, if this process is reversible, what will happen? S generation will be 0. If the process is reversible, S generation is 0. So if the S generation is 0, what will happen? This both are equal. Delta S will be equal to 1 to 2 del Q by T. If it is irreversible, right? If it is irreversible, what will happen? We will have some positive S generation value. So let it be like this. So this is a reversible process. This is an irreversible process. Okay, you have a reversible process, irreversible process. So reversible process, what will happen? S generation will be 0. You can directly integrate this equation and solve it. If it is irreversible, what is the problem? You cannot integrate this and find the answer because that will not match with the entropy, right? That will not match with the entropy. So what we will do, we will assume a reversible path, then we will integrate, you will get the answer. Why? Because whether it is a reversible process, irreversible process, doesn't matter. If your initial point and final point are same, entropy change will be same. Okay, because entropy is not a path function, it is a state function. Always remember this, बहुत सारे students को ये doubt होता है. Entropy change for an irreversible process and reversible process will be same if the initial and final points are equal. That if is important. Okay, if initial and final states are same, it is same. Entropy change is same. Okay, it will be same. If it is initial and final points are same, means it should be same because it is a state function, not a path function. Easy? So that is the important part. Yes, Rahul is asking, sir, entropy generation is occurring because of irreversibility? Definitely. Entropy generation is happening because of irreversibility. Now, what is the meaning of this equation? Right, what is the meaning of this equation, or what is the meaning of ds is equal to, if I am saying delta S is equal to, right, 1 minute, right, once again, what is the meaning of isentropic process here? Isentropic process, what is the meaning of isentropic process here? Isentropic process meaning is your delta S will be equal to 0. That is S1 is equal to S2. Okay, S1. Saril is asking, sir, S generation depends on the path. Definitely. If it is a reversible path, means S generation will be 0. Irreversible path, S generation will be positive. Okay. Now, isentropic process. When the process can be isentropic? The process can be isentropic when, if it is a reversible process. If it is reversible, what will happen? If it is a reversible, S generation is 0. If it is an adiabatic process, what will happen? Reversible adiabatic process. So if a process is reversible adiabatic, this adiabatic del Q is 0 and S generation is also 0. Then we can call it as what? Isentropic process. Entropy will be constant, right? Entropy will be constant. Yes, Rahul, internally reversible adiabatic process is isentropic. Very good, right? So this is the equation. Now, those who have confusion with the entropy, you can see here, right? You can see here, we have a process is happening, right? Process is happening inside the system, 0.1 to 2, right? 0.1 to 2. Now, we wanted to find what? Entropy change, right? We wanted to find entropy change. So delta S is equal to what? It is directly 1 to 2 del Q by T plus S generation. If this process happening inside is, right? If the process happening inside is reversible, this S generation is 0. Right? If the process happening is reversible, this S generation will be 0. If it is irreversible, definitely there will be what? There will be a extra value. But then this value, this path will become what? This path will become irreversible path. Okay? Then it will become irreversible path. This also you need to remember. Yes. Saril is asking, sir, reversible adiabatic can be isentropic. Okay, you are saying the answer. Okay, no problem. Yes, up to this is fine. Now, if they give you an isolated system, what is the meaning? If they give you an isolated system, what is the meaning of isolated system? Isolated system means you cannot have any heat transfer or mass transfer, nothing will be there. So if there is no heat transfer, means for an isolated system, your delta S will be equal to S generation. Your delta S will be equal to S generation. So inside an isolated system, if you have an irreversible process, so your delta S will be always greater than or equal to 0 for an isolated system. There can be only two possibilities. Okay, so based on isolated system, they can ask you question. Okay, isolated system means S delta S will be equal to S generation. दो ही possibility है, एक reversible हो सकता है, नहीं तो irreversible हो सकता है. ठीक है? Now, another question ये हो सकता है. So, what is the entropy change for a cycle? If it is cyclic irreversible process, okay? If it is a cyclic irreversible process, there was a question in GATE. Cyclic irreversible process. What is the entropy change? So, doesn't matter reversible, irreversible. Cycle का meaning क्या है? S1 minus S1. Initial and final points are same. So, cyclic irreversible process के लिए entropy का value क्या होगा? 0 हो जाएगा. Okay? Entropy change will be 0. Okay? Entropy change will be 0. Yes? Now, most important part, next part is, you can see here, we told ds is equal to what? Del Q by T. So, delta S find karna hai, so we need to know the integration, right? We need to know the integration reversible. So, 1 to 2, if I say 1 to 2 del Q by T, if it is a reversible process. Now, if it is an isothermal process, okay, like a vaporization process, okay, phase change process. If it is an isothermal process, what we can do is, we can take the temperature outside, so you can get whatever heat transferred divided by T. Out of the integration, you can take it, and you can say heat transfer divided by T if it is a reversible isothermal process. Okay, reversible isothermal process. Same way, right? Same way when you have thermal energy reservoirs. Okay, whenever we deal with thermal energy reservoirs, thermal energy reservoirs का मतलब क्या है? Thermal energy reservoir, if you are dealing with heat engine, source, sink, etc. मतलब this room is a thermal energy reservoir. Why? Because you have lot of things inside the room, but whatever heat is released, the temperature of the room is constant. Right? The capacity, thermal capacity of this room is very, very high. That is the meaning of what? Thermal energy reservoir. So, whatever happens, the temperature of the thermal energy reservoir is not changing. So, in thermal energy reservoir case also, you can use this equation. For example, you can see here. Example. We have a source. Okay? You have a source. This is your source. Source is at a temperature maybe 500 Kelvin. You have a sink. This room is a sink. Sink temperature is 300 Kelvin. Okay, source and sink. Now you have a heat transfer of 1000 joule to the source to sink. Okay, 1000 joule heat transfer is happening. Now, if you want to find temperature or entropy change of source, we can use directly Q by T. Why? We can use directly Q by T. Why? Because by this 1000 joule of heat transfer, your source temperature will never change. Okay, this is a thermal energy reservoir. Uska temperature ko koi farak nahi padega. Okay, in that case we can use it as what? What is the heat transferred? Heat is removed. Heat is lost. So it will be negative. Minus 1000 joule divided by what is the temperature? 500 Kelvin. Now what is the entropy change of sink? What is the entropy change of sink? Sink entropy change will be, the sink is getting heat, so it will be positive. So 1000 joule divided by 300 Kelvin. So what is the entropy change of total isolated system? Or entropy change of universe? System plus surrounding, right? System plus surrounding. So we can say system plus surrounding is equal to 1000 divided by 300 minus 1000 divided by 500. So this will be always greater than 0. Okay, this will be always greater than 0. Okay, so Saril is asking, sir, if we have two different irreversible paths, okay, you have two different irreversible paths, then change in entropy depends on S generation in respective path. So change in entropy is path function. No, change in entropy is never path function. You can see here, that is, if you are having different path, so this is one irreversible path, you can see here, this is one irreversible path. This is your one irreversible path, this is your second irreversible path. Okay, I have a different path also, this is my reversible path. In both three paths, your heat transfer will be different, right? Q will be different. This Q1, Q2, Q3 is different. So, if it is an irreversible process, right, your entropy will depend on heat transfer and entropy generation. No? That is, your equation is what? What is your equation? Delta S is 1 to 2 del Q by T plus S generation. If you are having two different paths, two different irreversible paths, that will depend on this term also, right? Entropy generation and this term will be there. So this is not same in all paths, right? Heat transfer will be different. Heat transfer is the path function. So each process के लिए heat transfer भी different होगा ना. लेकिन ये तीनों प्रोसेस का अगर इनिशियल कंडीशन एंड फाइनल कंडीशन सेम है तो एंट्रोपी चेंज सबका सेम होगा, है ना, क्योंकि एंट्रोपी इज ए स्टेट फंक्शन. इज इट क्लियर सरील? यस, I hope it is clear for you. Okay, so entropy change will be always positive. So entropy change positive का मतलब क्या है? अब सोचो, system plus surrounding, right? Here आपका जो hot body है, hot body's entropy is decreasing, cold body's entropy is increasing. लेकिन ये जो increase है ना, that is greater than this. So total entropy of the system plus surrounding will always increasing. ठीक है? टोटल एंट्रोपी ऑफ सिस्टम प्लस सराउंडिंग हमेशा इंक्रीज होगा। यहां पे एकदम इंपॉर्टेंट चीज मैं बता देता हूं। नाउ अगर ये 300 के जगह पे मैंने 499.99 रखा है सिंक का टेम्परेचर, इफ इट इज 499.99 यहां पे क्या आएगा, दिस विल बिकम 499.99 एंड ये होगा आपका 500, सो दिस विल बी अप्रोक्सीमेटली इक्वल टू 0 हो जाएगा। इसलिए हम बोल रहा था एंट्रोपी चेंज फॉर द कंबाइंड सिस्टम विल बी 0 इफ इट इज अ रिवर्सिबल प्रोसेस, बिकॉज यहां पे आपका जो हीट ट्रांसफर है ना, दैट इज रिवर्सिबल प्रोसेस। ओके, नाउ योर हीट ट्रांसफर इज रिवर्सिबल प्रोसेस। नाउ इट इनिशियली क्या था, वो इरिवर्सिबल प्रोसेस था। जब भी टेम्परेचर डिफरेंस ज्यादा होता है ना, वो इरिवर्सिबल प्रोसेस होगा। टेम्परेचर डिफरेंस बहुत कम है तो हम वी कैन से इट एज रिवर्सिबल प्रोसेस। ठीक है, सो दिस इज द पॉइंट। सो फॉर रिवर्सिबल प्रोसेस मैंने बोला था आपको डेल्टा एस फॉर एन आइसोलेटेड सिस्टम, रिवर्सिबल के लिए 0 होगा, इरिवर्सिबल के लिए ग्रेटर देन होगा। इस यूनिवर्स में वी डोंट हैव एनी रिवर्सिबल प्रोसेस, ऑल आर इरिवर्सिबल, इसलिए हमारा एंट्रोपी ऑफ द यूनिवर्स इज इंक्रीजिंग, राइट, इसलिए हमारा एंट्रोपी ऑफ द यूनिवर्स इज इंक्रीजिंग। नाउ मैंने स्टार्टिंग पे आपको बोला था एंट्रोपी का डेफिनेशन है ना, स्टार्टिंग पे आपको बोला था एंट्रोपी का डेफिनेशन, ये है डेफिनेशन। मतलब आप सोचो यू हैव अ हीट इंजन, राइट, सो आपका जो 500 केल्विन से अभी जो बोला था 300 केल्विन, यू हैव अ हीट ट्रांसफर, है ना, यू हैव 1000 जूल हीट इज ट्रांसफरिंग, you have 1000 joule heat is transferring. Yes, sir, temperature difference is very small, so that is the thing. Okay, so Dattara is asking, sir, थर्मो में ज्यादा क्वेश्चन कौन से टॉपिक पर होता है? नॉर्मली थर्मो 2 से आता है मैक्सिमम क्वेश्चंस, लेकिन थर्मो 1 फर्स्ट लॉ से आता है और एंट्रोपी से भी आता है। एवरी ईयर चेंजेस, ओके, एवरी ईयर चेंजेस, वी कैन नॉट प्रेडिक्ट इट, ठीक है, बिकॉज हमारे पास क्वेश्चंस अवेलेबल नहीं है, ठीक है, मतलब 2021 पे क्वेश्चंस जो आया था हमने ऑलरेडी आज डिस्कस किया है, 2021 का क्वेश्चन, 2019 क्वेश्चंस हमारे पास अवेलेबल नहीं है, ठीक है, बिकॉज पीपल दे डोंट रिलीज द आंसर्स, राइट, दे डोंट रिलीज द क्वेश्चंस आल्सो, वो भी प्रॉब्लम है ना, ठीक है। यस, सो हम यही बोल रहा था, आप देख लो यहां पे व्हाई वी आर सेइंग आफ्टर दिस पर्टिकुलर एनर्जी ट्रांसफॉर्मेशन, राइट, एनर्जी ट्रांसफर के बाद क्या हो रहा है, आपका एंट्रोपी, टोटल सिस्टम का एंट्रोपी इंक्रीज हो रहा है, लेकिन ये एंट्रोपी इंक्रीज हो गया, राइट, सो एनर्जी का क्या बात है, कुछ भी नहीं हुआ ना, मतलब एनर्जी इज कंजर्व्ड हियर, राइट, 1000 जूल रिलीज हो गया, वो 1000 जूल तो यहां पे मिल भी गया, राइट, व्हाट इज द प्रॉब्लम, किसी को प्रॉब्लम है? नो प्रॉब्लम, व्हाट एवर एनर्जी इज गिवन इज गेन्ड बाय द कोल्ड बॉडी, सो यहां पे एनर्जी का कुछ भी लॉस नहीं हो रहा है ना, 1000 joule is released by hot body, लेकिन that 1000 joule is gained by cold body, so there is no loss of energy, but लेकिन we lost something, right, we lost something because we lost the ability to use this heat energy, है ना, that is ये जो 500 Kelvin जो hot body है उससे हम heat engine चला सकते थे, है ना, we could have run a heat engine or we could have used this heat energy for any other useful purposes, लेकिन हमने यूज नहीं किया। यहां पे जो हीट ट्रांसफर हो गया, वो हीट ट्रांसफर के वजह से व्हाट हैपेंड, वी लॉस्ट समथिंग, वी लॉस्ट दैट क्वालिटी हीट, राइट, वी लॉस्ट दैट क्वालिटी हीट, वो जो हीट एनर्जी का क्वालिटी है ना, वो लॉस हो गया। मतलब इफ यू हैव अ स्टीम ऑफ क्वालिटी 0.98, वो स्टीम से हम कुछ भी कर सकते हैं, है ना, लेकिन स्टीम का जो क्वालिटी लॉस हो गया तो स्टीम का कोई मतलब नहीं है, वी कैन नॉट यूज दैट स्टीम इन हीट एक्सचेंजर। I hope you understood the idea of entropy. Okay, if the quality of the steam is 0.98, that steam can be used for different heat transfer purposes. लेकिन जब उसका quality loss हो गया तो we cannot do anything, right, with that steam. Okay, फिर से उसको heat देना पड़ेगा, ठीक है, so that is the important part, right, that is the important part, that's why मैंने बोला है आपको, so entropy quantifies the quality associated with energy transformations, राइट, जब भी एक एनर्जी ट्रांसफॉर्मेशन होता है, एनर्जी ट्रांसफर होता है, सो उससे एसोसिएटेड जो क्वालिटी लॉस है ना, उसके बारे में हम बोल रहे हैं, ठीक है, दैट इज द मीनिंग। सो आप ऐसे सोचो, राइट, आप ऐसे सोचो, यू केम टू द क्लास फ्रेश, मतलब सुबह 10 बजे क्लास में आ गए आप लोग, ठीक है, सो यू आर इन दैट मच एनर्जी ना, लेकिन आफ्टर 2 आवर्स व्हाट हैपेंड, यू वेस्टेड 2 आवर्स इन द क्लास, मतलब क्लास 12 बजे स्टार्ट हुआ है, सो आपने क्या लॉस हो गया, राइट? देयर इज नो, नथिंग इज लॉस, एनर्जी इज कंजर्व्ड, नो प्रॉब्लम, बट आपका जो क्वालिटी था ना 10 बजे का जो क्वालिटी था, दैट इज नॉट सेम एज 12 o'clock. यू लॉस समथिंग, राइट? दैट लॉस इज योर एंट्रोपी. वो लॉस के वजह से क्या हो गया, आपका रैंडमनेस भी इंक्रीज हो गया, डिसऑर्डर इंक्रीज हो गया, माइंड का डिसऑर्डर जो भी है. दिस इज द फिजिकल सिग्निफिकेंस. ओके, दिस इज द फिजिकल सिग्निफिकेंस ऑफ एंट्रोपी. नाउ ओके सरली सिंह सर, इक्विलिब्रियम वाले टाइप क्वेश्चंस जैसे ए वाला आया था, उसका कंसेप्ट बता दीजिए. कौन सा था? आई डिडंट अंडरस्टैंड द क्वेश्चन. इक्विलिब्रियम वाले टाइप क्वेश्चंस, which equilibrium, so please tell me, I didn't understand your question. ठीक है, so this is your entropy pi, right? Entropy में और क्या है equation important? Entropy में important equation ये है, you have du is equal to TdS minus PdV. ये equation important है. And you have dH is equal to TdS plus VdP. ये दोनों इक्वेशंस आपको याद रखना है. एंड मोस्ट इंपॉर्टेंट पार्ट ये है, ये दोनों इक्वेशन से यू शुड बी एबल टू डिराइव योर आइडियल गैस एंट्रोपी चेंज क्वेश्चन. मतलब इफ दे आर आस्किंग यू व्हाट इज द एंट्रोपी चेंज फॉर आइडियल गैस, du के लिए सब्स्टिट्यूट कर लो CVDT इक्वल टू TdS. P क्या है? इट इज RT डिवाइडेड बाय V. DH फॉर आइडियल गैसेस CPDT. So TdS, what is ideal gases volume? RT divided by P. So करो divide throughout, क्या हो जाएगा? It will become CV into dt by T, T से divide कर रहा हूं मैं, plus R into dV by V equal to ds. Again T से divide कर लो, CP into dt by T minus R into dP by P इक्वल टू ds. तो इसको इंटीग्रेट कर लो, आपको मिल जाएगा CV ln T2 by T1 प्लस R ln V2 by V1 इक्वल टू डेल्टा S. सेम वे सेकेंड टाइम CP इंटू ln T2 by T1 माइनस R इंटू ln P2 by P1 इक्वल टू डेल्टा S. सो जस्ट ये दोनों इक्वेशन एनीवे आपको थर्मोडायनामिक्स 2 से याद होना चाहिए, du एंड dH. सो वहां से इफ दे आर आस्किंग आइडियल गैस, यू शुड बी एबल टू डिराइव इट सिंपली, राइट? यू शुड बी एबल टू डिराइव इट सिंपली. ओके, डेफिनेटली दैट 4 ऑप्शंस आई विल एक्सप्लेन, राइट? सो वो थर्मो 2 में आता है, ठीक है? सो तब डिस्कस करेंगे, डोंट वरी. सो यहां तक ठीक है. दिस इज योर एंट्रोपी. एंट्रोपी के बाद यू हैव व्हाट? यू हैव मल्टी स्टेज कंप्रेशन विद इंटरकूलिंग होता है ना? एंट्रोपी में लास्ट चैप्टर होता है मल्टी स्टेज कंप्रेशन विद इंटरकूलिंग. सो फर्स्ट ऑफ ऑल, मल्टी स्टेज कंप्रेशन क्यों यूज करता है? सिंपल लॉजिक, राइट? व्हाई वी आर यूजिंग मल्टी स्टेज कंप्रेशन विद इंटरकूलिंग? क्योंकि हमें कंप्रेशन करना है, एक गैस को कंप्रेस करना है, तो क्या इंपॉर्टेंस है? व्हाट इज इंपॉर्टेंस? वी नीड टू प्रोवाइड वर्क, है ना? वी हैव टू प्रोवाइड वर्क. ओके, सो दैट वर्क रिक्वायरमेंट हमें रिड्यूस करना है. वी नीड टू रिड्यूस दैट वर्क रिक्वायरमेंट. ओके, कंप्रेशन वर्क का रिक्वायरमेंट हमें कम करना है. सो इफ यू वांट टू रिड्यूस द कंप्रेशन वर्क, वी हैव टू डू इट बाय व्हाट? By keeping the process isothermal, because isothermal is the most efficient process among all the other processes. ठीक है? So isothermal compression use किया तो हमें सबसे minimum work से काम हो जाएगा, है ना? So वो मैंने several times मैंने बताया भी है. That is, what is the equation for open system work? Open system work is equal to integral of VdP. So, अगर आपको ये वर्क डन कम रखना है ना? कंप्रेशन वर्क, ओपन सिस्टम कंप्रेशन वर्क, इफ यू वांट टू कीप दिस कंप्रेशन वर्क लोअर, आपको क्या लो रखना पड़ेगा? यू हैव टू कीप द स्पेसिफिक वॉल्यूम लोअर, है ना? यू हैव टू कीप द स्पेसिफिक वॉल्यूम लोअर, right? You have to keep okay. Cyril is asking du equal to TdS minus PdV equation की assumption only reversible होगा? No, reversible के लिए भी होगा, क्योंकि आप देख सकता है du is equal to TdS minus PdV में जितने भी equations use हुआ ना, temperature, entropy, pressure, volume, internal energy, all are state functions, right? all are state functions. So this equation is used for both reversible and irreversible processes. रिवर्सिबल इरिवर्सिबल प्रोसेस दोनों के लिए ये इक्वेशन यूज कर सकता है, ठीक है. लेकिन जब यहाँ पे हीट आता था, राइट, व्हेन इट वाज हीट वाज देयर, बिकॉज देयर वाज हीट इज व्हाट हीट पाथ फंक्शन होता है ना. रिवर्सिबल इरिवर्सिबल में यूज नहीं कर सकता, चेंज होगा, ठीक है. व्हेन इट इज TdS माइनस PdV, it is completely state function. So reversible process, irreversible process doesn't matter. Okay. Now, next. So हमें स्पेसिफिक वॉल्यूम कम रखना है. अगर कंप्रेशन की वर्क कम रखना है तो स्पेसिफिक वॉल्यूम कम रखना है. हाउ डू यू डिक्रीज स्पेसिफिक वॉल्यूम? स्पेसिफिक वॉल्यूम डिक्रीज करना है तो डेंसिटी ऑफ द गैस इंक्रीज करना है. अगर डेंसिटी ऑफ द गैस इंक्रीज करना है तो टेम्परेचर लो रखना है. ये कनेक्शन आपको समझ में आना चाहिए. यू नीड टू रिमेंबर दिस कनेक्शन. ओके, वी आर यूजिंग एनर्जी टू कंप्रेस समथिंग, है ना. वी आर यूजिंग एनर्जी टू कंप्रेस समथिंग. सो वो एनर्जी हमें रिड्यूस करना है तो हमें क्या रखना पड़ेगा? दिस इज द इक्वेशन. स्पेसिफिक वॉल्यूम कम रखना पड़ेगा. व्हाट इज स्पेसिफिक वॉल्यूम? 1 by density. 1 by density, so density should be increased. Okay, how can you increase, how can you keep the density of gas higher? By keeping low temperature. That's why you can see here, that's why when you are using multi-stage compression, right, when you are using multi-stage compression, they will be using an intercooler in between. They will be using an intercooler between. So the intercooler will cool your gas under constant pressure. For example, यहाँ पे आपका प्रेशर है 1 bar, टेम्परेचर इज 300 bar, सॉरी 300 डिग्री सेल्सियस और 300 केल्विन. नाउ हमें चाहिए द प्रेशर वी नीड टू कंप्रेस इज 25 bar. So by using, this is your first stage of compression, this is your second stage of compression. So we are compressing it into an intermediate pressure Px. So temperature is, for example, increased to 500 Kelvin after compression, है ना. कंप्रेशन के बाद टेम्परेचर 500 तक इंक्रीज हो गया. नाउ वी आर यूजिंग इंटरकूलर. इंटरकूलर से क्या होता है? कांस्टेंट प्रेशर पे कंप्रेशन होता है. सो टेम्परेचर इज डिक्रीज टू, मतलब कांस्टेंट प्रेशर पे कूलिंग होता है. सो टेम्परेचर इज रिड्यूस टू 300. सो टेम्परेचर लो रखा है. सो क्या होगा? आपका जो वर्क रिक्वायर्ड है ना वो कम हो जाएगा. Right, work required will be less. So this is the meaning of what? Multi-stage with intercooler, multiple stage compression with intercooler. Now, इसका equation क्या है? What is the general equation for reversible work done? So ये question आ सकता है, एक बार आया भी है BARC में भी. Reversible work is equal to number of stages multiplied by n into R T1 multiplied by gamma divided by gamma minus 1 into compression ratio power gamma minus 1 by gamma minus 1. This is your total equation. N is number of stages. Capital N होता है. Capital N is number of stages. Number of stages. N, small letter n क्या है? Number of moles. Okay. R is universal gas constant. T1 is initial temperature. क्योंकि हर स्टेज के लिए टेम्परेचर सेम होगा ना. 300 था इनिशियल टेम्परेचर. सेकेंड स्टेज के लिए टेम्परेचर क्या है? 300, क्योंकि हमने कूल किया है बीच में. सो जितने भी स्टेजेस होगा ना, हर स्टेज के लिए टेम्परेचर सेम ही होगा, बिकॉज हम बीच में इंटरकूलर लगा रहे हैं, है ना. वी आर यूजिंग इंटरकूलर. सो यू कैन सी गामा इज यू नो CP by CV. व्हाट इज CR? CR मैंने अभी जो बार सेशन में भी बोला था. CR इज इक्वल टू योर फाइनल प्रेशर डिवाइडेड बाय इनिशियल प्रेशर power 1 divided by n, where n is the number of stages. So इस question के लिए CR क्या होगा? What will be the CR for this case? It will be P2 is 24, P1 is 1, power 1 by 2, क्योंकि only 2 stages are there. So 5 bar will be the interstage pressure. So they can ask you by giving this diagram, what is the interstage pressure? Okay, so that is also there. I hope that is also done. So that is the end of your थर्मो 1 है ना, ये हो गया आपका थर्मो 1 फिनिश. Now we'll go for thermo 2. Okay, we'll go for thermo 2. Yes, up to this I hope there are no other doubts. So thermo 2 जाते हैं. So thermo 2 में क्या क्या है आपको? You have to remember 4 equations. I always start thermo 2 from here. Okay, U plus PV H A plus PV G है ना. This direction it is always plus PV, this direction it is always minus TS. So U plus PV is H, A plus PV is G. U minus TS is A, Helmholtz free energy, H minus TS is G. So we don't have time for physical significance because already मैंने 2-3 बार sessions में बताया है. So important is 4 equations are important. Du is fundamental property relations. Du is equal to TdS minus PdV. dH is equal to TdS plus VdP. dA is equal to minus SDT minus PdV. And dG is equal to VdP माइनस SDT. सो ये होगा आपका स्टार्टिंग 4 इक्वेशंस है ना, ये आपके स्टार्टिंग 4 इक्वेशंस है. सो यहां से यू शुड बी एबल टू राइट द मैक्सवेल रिलेशंस एज वेल है ना. ये 4 इक्वेशन से यू शुड बी एबल टू राइट द मैक्सवेल रिलेशन. आई एम नॉट रिपीटिंग इट अगेन क्योंकि ऑलरेडी मैंने 2-3 बार मैक्सवेल रिलेशन आई हैव डन, राइट. सो आई हैव ऑलरेडी डन इन यूट्यूब एज वेल 3-4 टाइम्स. सो this is the first thing, right? This is the first thing. Once Maxwell relations are done from thermo 2, once Maxwell relations are done in thermo 2, directly you should remember what? Your Clausius-Clapeyron equation. So based on Clausius-Clapeyron, they can ask you question. What is the Clausius-Clapeyron equation? That is this year gate also they have asked a question. ln P2S divided by P1S is equal to delta H by R into 1 by T1 minus 1 by T2. Okay, so this is the equation. Now in gate 2022 there was a question, right? There was a question, basic question. That is, when a liquid phase and when a vapor phase are in equilibrium, when liquid and vapor phases are in equilibrium, what are the things that will be same? है ना, liquid and vapor are in equilibrium. क्या क्या चीजें same होगा? First of all, if liquid and vapor are in equilibrium, temperature of liquid and temperature of vapor will be same. Pressure of liquid and pressure of vapor will be same. है ना. अगर आपको confusion है तो आपको क्या करना है, आपको directly एक thermodynamics book से you can see the back side of the thermodynamics book for steam table, right? Check the steam table and take the temperature as 100 degrees Celsius. Pressure will be automatically fixed at 1 atm. है ना. So pressure will be 1 atm, temperature is 100 degrees Celsius, water is boiling. Now क्या क्या equal नहीं होगा? Internal energy of liquid phase will be less than internal energy of vapor phase. Enthalpy of liquid phase will be less than enthalpy of vapor phase. Entropy of liquid phase will be less than entropy of vapor phase. है ना. Enthalpy किसको ज्यादा होगा? Vapor को ज्यादा होगा ना. Obviously यार, logically भी सोचो, right? If you heat the water for 10 minutes, उसमें हाथ डालो तो क्या होगा? Your like hand will be burnt. Why? Because the enthalpy of that system is more, because it has more vapor. So more vapor मतलब क्या है? More heat content होगा ना. ठीक है? So आपका internal energy same नहीं होगा. Same way, specific volume of liquid will be less than specific volume of vapor. Right? Specific volume of vapor will be very, very high, right? Compared to specific volume of liquid. So this is internal energy of vapor ज्यादा होगा, entropy of vapor ज्यादा होगा, enthalpy ज्यादा होगा, specific volume भी ज्यादा होगा. Only these two things will be equal. Now एक और चीज equal होगा, that will be your fugacity. Fugacity of liquid and vapor phase will be equal, or you can say Gibbs free energy of liquid and vapor phase will be equal. If the Gibbs free energy is equal, we can say chemical potential of liquid phase and vapor phase are equal. Okay, when a liquid and vapor, if a pure substance, liquid and vapor are in equilibrium, and whenever there is a vaporization, we will say Gibbs free energy of liquid phase and Gibbs free energy of vapor phase are also equal. ये गिब्स फ्री एनर्जी इक्वल होता है, इसलिए हम बोलते हैं कि हमारा केमिकल पोटेंशियल भी सेम होता है ना. व्हेन केमिकल पोटेंशियल इज सेम देन वी कैन से मल्टीपल से अगर if it is a multiple component mixture, we will talk in terms of what chemical potential as well. Okay, chemical potential, that is your what partial molar Gibbs free energy, वो हम बाद में discuss करेंगे. ठीक है, so these are the part. Okay, so in your gate there was a question based on this same thing. Okay, there was a question based on this. Yes, Saril is saying, sir, quality is high means मतलब mass of vapor is more obviously, और right, quality ज़्यादा है तो mass of vapor ज़्यादा ही होगा, क्योंकि आपका अगर quality ज़्यादा है और always at a particular temperature and pressure आपका entropy of vapor ज़्यादा होगा ना. So quality का equation, for example, entropy of a system आपको calculate करना है. कैसे calculate करोगे? X into entropy of vapor plus 1 minus X into entropy of liquid. So, अगर आपका क्वालिटी ज्यादा है, फॉर एग्जाम्पल अगर आपका क्वालिटी है 0.9 है वेपर की, राइट, वेपर की क्वालिटी 0.9 है, तो क्या होगा, आपका एंट्रोपी ज्यादा हो जाएगा, है ना, एंट्रोपी विल बी हाई, राइट. सो हियर द क्वालिटी इज नॉट द क्वालिटी वी वर डिस्कसिंग एट दैट पर्टिकुलर थिंग, राइट. क्वालिटी ऑफ मिल्क डिफरेंट होता है, क्वालिटी ऑफ वेपर डिफरेंट होता है ना. मिल्क का क्वालिटी मतलब मिल्क का वो मतलब कैरेक्टर बोल रहे हैं हम, है ना. क्वालिटी ऑफ वेपर मतलब दिस डिफरेंट, 90% वेपर, दैट इज द क्वालिटी हियर. ओके, दैट इज इंपॉर्टेंट. यस, सो 0.9 एक्स इज 0.9 मीन्स व्हाट, यहां पे वेपर की एंट्रोपी ज्यादा होगा, सो एंट्रोपी ऑफ द सिस्टम विल बी मोर. ठीक है, यस. So once this is done, we will move to fugacity. Fugacity chapter में क्या क्या important है आपके लिए? dg is equal to RT dlnp होता है for ideal gases. If it is a real gas, we can write dg is equal to RT dlnf for real gases. So we can say delta G for a real gas is equal to delta G for ideal gases plus RT ln phi, where what is phi? Phi is fugacity divided by pressure. So limit P tends to 0, F by P will be equal to 1. ये सारे equations आपको याद रखना है ना. Now if you take this way, if you take a standard state, G real gas G will be equal to ideal gas G plus Gibbs free energy of ideal gas plus RT ln phi. So here G minus G ideal gas is known as G residual. So G residual by RT is also equal to ln phi. So any residual property is property of real gas minus property of ideal gas. So gases के लिए we will call residual property. In case of liquids, you have excess property, property of a real solution minus property of ideal solution. So ये दोनों compare करके आपको पढ़ना चाहिए, then only you will be able to remember the equations. Easy. Now, how do you calculate fugacity? For calculation of fugacity, आपके पास there is a lengthy equation is there. So ln phi is equal to, we have discussed several times in class. By using compressibility factor, you have an equation Z minus 1 by P dP. This is using compressibility factor, which is also equal to 0 to P. This term is also equal to residual volume divided by RT into dP. Residual volume का मतलब क्या है? Residual property क्या है? Actual volume minus ideal gas volume. Okay? So this is also equal to what? GR by RT. So this is your complete equation needed for fugacity chapter. First chapter में इतना काफी है for solving all the questions. Okay? So calculation of fugacity is based on residual Gibbs free energy based. You can calculate. You can calculate by using residual volume. You can calculate by using compressibility factor. So these are the total equations. Yes, I hope it is clear for everyone. Yes. Now, once this is done, you have solution. Solution thermodynamics is starting. So solution thermodynamics, the most important equation is what? Your total property is equal to number of moles into molar property. So any molar property of a solution, real solution, can be written as xi into mi bar, where your partial molar property is equal to total property differentiated with respect to number of moles at constant temperature, pressure, Nj. So any partial molar property, if they are asking you to find V1 bar, it will be V minus x2 into dou V by dou x2. V2 bar is V minus x1 into dou V by dou x1. So these two equations needed to be remembered. So इस इक्वेशन का एग्जाम्पल क्या है? दैट इज इफ यू वांट टू फाइंड द गिब्स फ्री एनर्जी ऑफ ए सॉल्यूशन, गिब्स फ्री एनर्जी ऑफ ए सॉल्यूशन बाइनरी मिक्सचर, यू कैन राइट x1 into g1 bar plus x2 into g2 bar. Or what is partial molar Gibbs free energy can be written as chemical potential x1 mu1 plus x2 mu2. So these are the basic equations you need to remember. Now comes your famous ideal gas mixture model. So understanding ideal gas mixture model is important. Ideal gas mixture model. Ideal gas mixture model. So what is the meaning of ideal gas mixture model? Ideal gas mixture model is defined as your partial molar property of an ideal gas mixture at temperature T and pressure P is equal to any pure gas property, pure ideal gas property at constant temperature and partial pressure. This is except for volume. Except for volume. I have explained this several times, so I am just writing the equation now. So if they are asking you partial molar enthalpy in an ideal gas at temperature T, P, this is also equal to enthalpy of an ideal gas at temperature, partial pressure, and this is also will be equal to enthalpy at temperature, pressure also, because your enthalpy, internal energy, etc. does not depend upon the pressure. So whatever is the value of pressure, right, in mixture and pure substance, it will be same. But if it is Gibbs free energy and entropy, this is the problem, right? Gibbs free energy at temperature T and P will be equal to Gibbs free energy in an ideal gas at temperature T, partial pressure A, Pi, okay? Entropy at temperature and P will be equal to pure component entropy at temperature, partial pressure Pi. So these equations you need to remember. Now you can see here, if you want to write this equation, Gibbs free energy of component A, in the mixture, if you want to write it is equal to Gibbs free energy of component A with the same temperature and pressure, you have to add a term RT ln YA. Same way, if you want to write entropy in the mixture at temperature and pressure is equal to pure component entropy at temperature and pressure, these two are not equal, so to make it equal you have to write minus R ln YA. Okay, minus R ln YA. So these two equations are very important for us. Once these two equations are done, you have property change of mixing. You have property change of mixing. property change of mixing. So what is the meaning of property change of mixing? So we can see here property change of mixing is any property is equal to xi into mi plus delta m. So delta m is your property change of mixing. Delta m can be written as sigma xi into mi bar minus mi. So from this equation you can see here, if you want to write delta G ideal mixing, you can see here, you will have these two will be minused. So your equation will be equal to sigma Ya into RT into sigma Ya into ln Ya. Same way, delta S mixing for ideal gas will be equal to minus R into sigma easy. So property change of mixing will also be done. Last equation you have is, or with one equation we can finish this particular chapter, that is G is equal to, right, G is equal to Gxs plus sigma xi into Gi plus we can say RT into sigma xi ln xi. Or this is general equation is m is equal to mxs plus sigma xi mi plus delta m ideal mixing. So this is a general equation. So इसके ऊपर भी question आता है. So if it is asked, they are asking entropy, आपका equation होगा entropy xs plus sigma xi into si plus delta s mixing ideal. So finally equations are coming to लेकिन आपका जो बेसिक बार्क में मोस्टली क्वेश्चंस आर बेस्ड ऑन दिस इक्वेशन, दैट इज ये सिस्टम आपको रिमेंबर करना होगा, दैट इज यू हैव फॉर एग्जांपल अल्कोहल प्लस वाटर सिस्टम. ओके, यू हैव सम एथेनॉल प्लस water system. Your ethanol is component 1, water is component 2. So when you mix ethanol and water, you know the mole fraction in liquid phase XA and mole fraction in vapor phase, mole fraction in liquid phase for XA and XB, or X1 and Y1, X1 and X2. You know X1 and X2. Now, in the vapor phase, you don't know what is the composition in the vapor phase at this temperature and pressure. So for finding how much vapor phase ethanol is present, that will be denoted by Y1. How much vapor phase water is represented, that will be represented by Y2. So you have a basic equation. What is the basic equation? Phi 1 bar Y1 into P is equal to X gamma 1 into X1 into P1S. This is the general equation. Okay, this is the general equation. If they have given dilute solution, instead of P1S, you can write Henry's Law's constant. Itna hi to change hai. So, if they give you ideal solution and ideal vapor phase, ideal liquid phase, means this equation will turn into Y1P is equal to X1 P1S. This is your Raoult's law. If it is vapor phase is non-ideal, if they give you vapor is non-ideal and liquid phase is ideal, so it's very simple. Phi 1 bar Y1P is equal to X1 P1S. Now for finding the value of gamma, they can give you different correlation. So most of the cases, they will be giving you this correlation. Gxs by RT is equal to x1 ln gamma 1 plus x2 ln gamma 2. Most of the cases, they will be giving you this correlation. So based on this, you can solve. Clear? Now once this is done, with this, your whole phase equilibrium is completed, or phase equilibrium and your solution thermodynamics is done. Last chapter you have is chemical reaction equilibrium. In chemical reaction equilibrium, you need to remember only two formulas. First formula to remember is standard Gibbs free energy change is equal to minus RT ln K. And for K, you have only this equation. K is K phi Ky into P power nu. Now, K is independent of pressure, right? K is independent of pressure. In the last induction program also I have mentioned this. K is independent of pressure. Now, if nu is positive, what will happen? When we increase the pressure, P power nu will increase. So then we have to keep Ky. Your Ky will decrease. So if you want to have more conversion, what you have to do in this case, you need to decrease the pressure. Opposite case will be opposite. That is, if you have nu negative, if you increase the pressure, you will have more conversion. Okay, so understanding this is important. So this is the total relation you need to remember for, this is the total relation you need to remember for what? Chemical reaction equilibrium. And you have degrees of freedom is the last topic. So degrees of freedom, I've already discussed in the same channel, chemical channel. We have solved all the PYQs of degrees of freedom. It's only 20 minutes video. Okay, so just go through the complete degrees of freedom video that is available in your playlist of new channel, chemical engineering new channel. So with that, your complete thermodynamics equations is done. Okay, so with that we are finishing. So from tomorrow, one more important announcement. From tomorrow we are starting fluid mechanics in the live app. So we will keep the class timing somewhat 3 to 4 hours, so that before BARC at least some topics are covered. Okay, so those who have not attempted fluid mechanics so far, so it may be helpful for you in the BARC exam. We will try to discuss more topics before April 2, so that you will have more understanding of fluid mechanics in the BARC exam. That's all. Thank you very much. See you all tomorrow. Okay, thank you.